Questions and solutions. Given the integration of f of t dt between 1 and 2 equal to 5. Find the integration between 2 and 1 of the function open parenthesis f of t plus 2 close parenthesis dt. The way to handle this one is to break it into two functions, and here are the two functions. Integration between 2 and 1 of f of t plus 2 dt equal to integration between 2 and 1 f of t dt plus integration of the number 2 between 2 and 1 dt. And this is equals to, because we're going to change the limits, this is equal to negative of integration between 1 and 2 of f of t dt, which is equal to 5, as we see over here, minus integration between 1 and 2 of the number 2. We can proceed with them as follows. This we already know that without the negative 1 multiplied, this will give us 5 based on this equation. So negative 5. And this we have to integrate 2 dt, that will give us 2t, and we have to evaluate the 2t between 1 and 2, where 1 is lower and 2 is higher. If we do the math, we're just going to have and plug in 2 instead of t, and then minus plugging 1. That will give us 4 minus 2, and the ultimate answer will be negative 5 minus 2, and that will give us negative of 5 plus 2, which is equal to negative 7. That is the answer for this question. Let's move on to the next question. Evaluate the integration between 0 and 1 of the rational function 1 divided by 1 plus x squared dx, given the integration between negative 1 and 1 of the rational function 1 plus x divided by 1 plus x squared dx equals to pi over 2. Now, the given function, which is on the left-hand side in black, equal to pi over 2, implies we can split the given function based on the numerator, and that will give us two functions, the blue function and the brown function. Since these two functions will add up to the given function, then the two functions will be equal to pi over 2, just like the given function. Now we will look at the integration of the brown function. The brown function here, if we look at its integration, we can tell that if we multiply the numerator by 2 and divide the integration result by half, then we will be able to get the integration of the brown as half ln of the absolute value of 1 plus x squared evaluated between negative 1 and 1, and the evaluation will result into 0, simply because x squared. So that means the brown contributes nothing. So that means the given function, which is the left-hand side over here, its integration equal to 1 over, it is equal to pi over 2. Also, the integration of the blue will result into pi over 2. So we will focus on the blue, and we know that the blue will evaluate to pi over 2. So we will use the blue to figure out the integration of the red, which is the one that we're supposed to evaluate. So we can break down the blue into two functions, but this time not based on the numerator, but based on the limits. And if we divide it into two integrations based on the limits, this is what we're going to get. And you can see that the red one matches what we're supposed to evaluate. So we have to figure out the value for the black one. So let's figure out the value for the black one. And we can see that we have 1 plus x squared in the denominator, and that implies that maybe we should make some changes over here. So instead of integration of an algebraic function, let us make it integration of a trigonometric function. And for that we need a triangle. Let's take a look at this triangle. This triangle has an angle theta over here. It's right angular triangle, and we have theta over here, and the opposite side is x, and the adjacent side is 1. So the hypo will be square root of 1 plus x squared. Let us get some information from this, and then we will proceed with integration. First of all, if we look at tan theta, it's going to be equal to x divided by 1. So if tan theta equal to x, then if x is equal to 0, that means theta must be equal to 0. And if x equal to negative 1, this implies theta is equal to negative pi over 4. We're just looking at the limits of the integration. So we have the limits of integration, negative 1 and 0. So when x is equal to 0, this implies theta will be 0. When x is equal to negative 1, this implies theta will be negative pi over 4. Now we will look at the derivative of tan theta. If we do the derivative of tan theta, it's going to give us sec squared theta d theta. And derivative of the right hand side, which is x, will give us 1 dot dx. We will keep this one because we need to replace dx also. Now we will look over here and see that if we do the cosine of theta, we're going to get 1 divided by square root of 1 plus x squared. So this is cosine theta, 1 divided by 1 plus square root of 1 plus x squared. So if we square cosine theta, we'll give cosine square theta equals to 1 over 1 plus x squared. Now we can just go ahead and replace the integrand over here. So the integrand is no longer going to be 1 divided by 1 plus x squared, but it's going to be what? Cosine square of theta. And dx is going to be replaced by sec square theta d theta. And this is what we're talking about. So this is the function on the left, and this is its equivalent on the right. This is the algebraic, and this is the trigonometric, but both of them will give the same integration. So let's proceed with integration of this one. Luckily, what we have is we have a function multiplied by the reciprocal of that function. So these two will end up giving us integration of just 1 d theta with the same limits. 1 d theta with the same limits. If we do the math, then we're going to be integrating 1, that will give us theta. We have to evaluate theta between negative pi over 4 and 0. If we do so, the result will be equal to pi over 4. So now we know the value of the black, and the only thing we need is the value of the black. So the black will contribute pi over 4. We need the value for the red, and we know the right hand side. So what does that mean? Since the black is equal to pi over 4, then we said the integration, the blue, will be equal to the black, which is pi over 4, plus the one that we're supposed to evaluate, plus 0 for the one that we already canceled because it will contribute nothing, and that's equal to pi over 2. So we can take the pi over 4 to the other side, and that will tell us that the red, which is the one we're supposed to evaluate, is equal to pi over 2 minus pi over 4, which will give us pi over 4. So this is what we need to as the answer for the question. The evaluation of this integration will result in pi over 4, and this is the answer. Let's go to the next question, or let's try to solve this problem but using a different method. This is the same problem that we did in the previous slide. The only difference that we're going to be making here is that we're not going to use the triangle. So let's get going. Here is the function, the given function in the left hand side. On the right hand side is just the division of this function into two functions. So we're making two integrations. We've already shown that the integration of the brown will result in 0, and for convenience we're repeating it over here. So the integration of the given function is the same as the integration of the blue function in value. So let's go ahead and look at the original function. The original function, its integration, as we said, is the same as the integration of the blue function. Now, the blue function can be divided or split into two parts depending on the limits, and that will give us the black and the red. The red one matches the function that we want to evaluate its integration. So we have to figure out the value of the black one. But we know that the integration of 1 divided by 1 plus x squared will result in tan inverse of x. So we could use that substitution. So we're going to substitute, instead of 1 divided by 1 plus x squared integration between -1 and 0, we'll just say that the integration will result in tan inverse of x evaluated between -1 and 0, and that will give us tan inverse of 0 minus tan inverse of -1. And that, if we evaluate them, that is going to give us an angle of 0 minus negative pi by 4, which is the angle resulting from -1. And that's going to give us pi divided by 4. Since it's going to give us pi divided by 4, then we can conclude that the integration of the original function equals the integration of the blue function plus the brown, which is 0, but the blue function we divided into a black function and a red function. The black function, now we proved that its integration is pi by 4 plus the red function plus 0. That's going to give us pi over 2. So we can take the pi over 4 to the right hand side, and that implies that the red is going to be equal to pi over 4. And that ends this proof. This is a shortcut. This is shorter than the one we showed in the previous. So that's it for this problem. Let's move on to the next problem. Integrate the following function. We want to find the integral of 3 divided by x ln x. So we want integration of the function 3 divided by x ln x dx. Let u equal to ln of x. This implies du, which is derivative of the left, equal to 1 over x dx, which is derivative of the right. If we multiply both sides by x, we get dx equal to x times du. Now we just plug in, instead of ln x u, instead of dx, we will put x du. And that's going to be something like this: integration of 3 divided by x, and this is u, which represents ln x, and this is x du, which represents dx. Now we can see that the x cancels with the x, and we have just integration of 3 divided by u du. So we take the 3 out, we'll have 1 divided by u du. Since the derivative of u is equal to 1, because we're integrating with respect to du, then this will yield 3 ln of the absolute value of u plus a constant, because we don't have like integration from lower limit and upper limit, and that's why we have to put the constant of integration. That's going to be equal to plus c. So our final answer will be 3 ln of the absolute value of ln x plus c. That is the answer for this problem. Find the integral of 3 e to the power 2x cosine of e to the power 2x dx. We will also use integration by substitution. So let u be equal to e to the 2x. Then du is equal to 2e to the 2x dx. This implies dx equal to du divided by 2 times e to the 2x. Now we will just be plugging in values. So integration of 3e to the 2x cosine of e to the 2x dx is going to be equal to integration. We leave 3e to the 2x aside. Cosine, instead of e to the 2x, we replace that by u, and then we multiply that by dx. We know that dx is equal to du divided by 2 times e to the 2x. So we replace it here, du divided by e to the 2x. So e to the 2x cancels e to the 2x, and we'll have 3 divided by 2. We'll take it outside of the integration, and that's what we have, 3 over 2, and then integration of cosine u du. Neat and clean. So integration of cosine u is going to give us sine u. So that's going to give us sine u plus constant. So 3 divided by 2 sine u plus constant. And that is the answer. So the answer is 3 divided by 2 sine. Instead of u, we replace it by the value of u, which is e to the 2x plus constant. And that ends this problem. Replace the integrand by its equivalent trigonometric value. What we have here are just algebraic expressions in terms of a rational function. We want to replace the integrand, which is this. We want to replace it by trigonometric functions. To do so, we have to think about what value x should have. So let x be equal to 1 over 3 tan theta. If x is equal to 1 over 3 tan theta, let's do the derivative of both sides. So dx will be equal to 1 over 3 sec square theta d theta. This implies the following. Integration of 1 divided by x square, square root of 9x square plus 1 dx equals to integration. We're going to leave x square as it is for now. And then numerator is the same, 1 divided by, in the denominator, instead of x square, we're going to plug in its value. If x is equal to 1 over 3 tan theta, then x square will be 1 over 9 tan square theta, which is right here, 1 over 9 tan square theta. So this x square in black is replaced by 1 over 9 tan square theta in blue. Now we can see the 9 cancels the 9, and we'll be left with tan square theta plus 1. But also dx has this red value, which is 1 over 3 sec square theta d theta. So we replace dx. This dx is replaced by 1 over 3 sec square theta d theta. Now we can do some cleaning. We can see that x9 cancels the 9, so we have tan square theta plus 1 inside. And outside we have 1 over 3. 1 over 3 is coming from dx. So we have 1 over 3 and then 1 divided by x square, square root of tan square of theta plus 1 multiplied by, this is part of the dx equivalent, because the 1 over 3 we move it to the left of the integration. So this is what's remaining in red is from the equivalent of dx. Let's move on to the next step. So we have 1 over 3. Now we're going to have to replace x square by its value. We know that the value of x square is 1 over 9 tan square of theta. So it's right there in blue in the denominator. Instead of x square, we replace it by 1 over 9 tan square of theta. But we know that 1 over 1 over 9 takes 9 to the numerator. So the 9 could go up here. That will be 9 over 3. And then we have tan square theta multiplied by sec theta. Where did we get sec theta from? We know that the square root of tan square plus theta is same as the square root of sec square theta. That is tan square theta plus 1 equal to sec square. And since we have the square root of sec square, we're going to get sec theta only. So sec theta is the result of replacing the square root of tan square theta plus 1, because tan square theta plus 1 is equal to sec square theta. So the square root goes and we will have sec of theta. And this is multiplied by the remaining of the dx equivalent, which is sec square theta d theta. Now we can see that we can cancel one of the sec from the numerator. So the denominator will cancel sec of theta. So we will have only just sec theta. You can see we have sec theta here and no sec theta in the denominator, just sec theta in the numerator, because this is sec square theta. So we have 9/2 integration between 1 divided by tan square of theta multiplied by sec of theta d theta. Let's go ahead and rewrite tan theta. Okay. We could just flip this up. Instead of tan theta, it would be cotan of theta square. Instead of tan theta, 1 over tan theta square, we will put cotan theta square. And that will give us what? Cosine square of theta divided by sine square of theta. And of course, 9 divided by 2 will give us 3. So cosine square theta divided by sine square theta multiplied by sec of theta d theta. We know that sec is the inverse of cosine, so even this sec theta in red is going to take care of one of the two multiplied cosine theta. No, cosine theta multiplied by cosine theta, so we're going to get rid of one cosine theta. We'll be left with cosine theta only, and sec theta will disappear with the other cosine. So we will have just cosine theta divided by sine square of theta d theta. We don't have to carry on the integration. We just want to replace this integration to integration of the integrand, which is trigonometric function. So let's go ahead and look at this. This is equivalent to 3 multiplied by cosine theta divided by sine theta multiplied by 1 over sine theta d theta. So we can rewrite this one as 3 integration of, this is cot theta, so cot theta, and this is cosec theta d theta. And that ends this problem. Now we have to compute the integral of x to the power 5 plus 2 divided by x squared minus 1 dx. And this is a little bit difficult, so we have to do the division. We cannot just factor out the denominator. That will be a long way, and we may not even get even there. So let's just go ahead and do division. We divide the numerator by the denominator. So if we divide x to the power 5 plus 1, x to the power 5 plus 2, if we divide it by x squared minus 1, the result will be as follows. Let's follow it step by step. What we're going to divide is x to the power 5 plus 2. The divisor is x squared minus 1. Since x to the power 5 is greater than in order of x to the power 2, then we can divide this. So x to the power 5 divided by x to the power 2 will give us x to the power 3. Now since this is x to the power 3, we have to multiply it by the divisor and list it down. So if we multiply by the divisor, x to the power 3 multiplied by x to the power 2 will give us x to the power 5. And then x to the power 3 multiplied by negative 1 will give us minus x cubed. Now we have to subtract this line from the top line. So x to the power 5 will go with x to the power 5, and we have 2, and then we have to subtract from 2 negative x to the power 3, so it will be x to the power 3 plus 2, all positive. Now x to the power 3 still is greater in order than x to the power 2, so we can perform division. X to the power 3 divided by x to the power 2 will give us x, so we will put plus x here. Now we have to multiply x by the divider, so x times x squared will give us x cubed. Then x times negative 1 will give us minus x. Now we have to subtract this line from the line on the top. We can see that x cubed goes with x cubed, and we'll be left with 2 minus negative x, so it will be 2 plus x. I just put it as x plus 2. Now the division resulted in this, the result, this is the divisor, and this is the remainder. So we can rewrite the function x to the power 5 plus 2 divided by x squared minus 1. We can rewrite it as x to the power 3 plus x, which is what? Which is the answer. Okay, so this is the answer. So we put that without involving anything else, and then plus the remainder we have to divide it by the divisor. So the remainder is x plus 2. We have to divide it by the divisor, which is x squared minus 1. So we'll do it in two terms. So we'll say x divided by x squared minus 1 plus 2 divided by x squared minus 1. Now, to do the integration of the left-hand side, we have to perform the integration term by term of the right-hand side. So do the integration of the first term. It will give me x to the power 4 divided by 4. Second term will give me x to the power 2 divided by 2. Third term, we can see that we can use ln. Why? Because the numerator is not really the derivative of the denominator. We have to make a trick, and the trick is we have to make the numerator derivative of the denominator. What's the derivative of the denominator? Is 2x. So we have to multiply 2 on the top, and then we have to divide the result by 2. So dividing by the result by 2 is just writing 1 over 2. And then if we take the integration of 2x divided by x squared minus 1 will give us ln of the absolute value of x squared minus 1. I mean, by now you should be able to understand that the result of integration of this is going to give us half of ln of this. And then from here on, we have to do this one. So this one is 2 divided by x minus 1. So this is the whole integration that's left. All the integrations on the previous ones are done except this. So this one we have to do integration by parts. And 2 divided by x squared minus 1 will be equal to a divided by x minus 1 plus b divided by x plus 1. If you do cross multiplication, you're going to get the left-hand side will be the same. Right-hand side will be ax plus bx minus b. And if we rearrange, we know that we have two coefficients, coefficients of x and coefficients that are coefficients of x to the power 0, or constant terms, another way. So if we look at the constant terms, we have only one constant term, which is 2. That means 2 is going to be equal to the constant term over here, which is a minus b. We have a as a constant term and b as a constant term. So a minus b is equal to 2. And the coefficient of x, of course, we have ax plus bx. So a plus b is a coefficient of x. And coefficient of x here is 0. So a plus b equal to 0. Now if we add these two, it will give us 2a equal to 2. That means a equal to 1. And since a plus b equal to 0, so b must equal to negative 1. And if that is the case, we're just going to go ahead and plug in instead of a 1, plug in instead of b negative 1, and do the integration. And if we do the integration, we're going to get this. The first will give us ln of absolute value of x minus 1 minus the second will give us ln absolute value of x plus 1. Okay. and then we can just group these two in green. It will be ln of the absolute value of x minus 1 divided by x plus 1, the absolute value, plus constant, because this is the constant of integration. This is the answer of the integration. This could be rewritten in a different way, but we're going to stop right here, and that ends this problem. Let's go to the next problem. This is the last question, and it's about using the velocity formula. V of t equal to t squared minus 6t plus 8. This is the formula for the velocity of an object moving on a straight line. We want to find the distance traveled between t equal to 0 and t equal to 3. We can do that by just taking the distance. The distance is the integration of the velocity. So integration of the velocity is going to be integration of t squared minus 6t plus 8 dt. And that's equals to, term by term, this will be 1 over 3 t cubed minus this will be 3t squared plus this will be 8t. And of course, we don't want to add a constant because we know that we have the limits of the integration 0 and 3. So we'll just go ahead and do the plugging. So to find d of t between 0 and 3, these are the limits of integration. We evaluate the distance between 0 and 3, but we know that 0 is going to result in 0. So we'll just evaluate the function and replace for every t the value 3, and that will give us the distance. If we do so, 1 over 3 multiplied by 3 to the power 3, that's going to give us 3 to the power 3, it's going to give us 27 divided by 3 will give us 9. And this is 3, negative 3 multiplied by 3 squared. 3 squared is equal to 9. 3 times 3 squared is going to give us 27, so minus 27. And 8 multiplied by 3 will give us 24. And if we do the math, we can see that this will result in 6 meters because the unit is meters. So the distance traveled will be 6 meters. And that's the end of this. And that ends the quiz. So good luck and see you for the next quiz.